class A and class AB. Now class A, it is just one transistor. So the transistor will only work on one side of the half cycle. Alright, and also note that being a BJT, from base to your emitter, it is actually a diode. And for a diode to conduct, you need at least to provide some amount of voltage to overcome the barrier. And that is about 0.6 volts. So even though it is only operating half cycle, even let's say for example at a positive cycle, you need to have at least 0.6 before the whole device can turn on. Alright? So in other words, the whole system will click, instead of at 0 volts, it will click at 0.6 volts. Alright? So as a result, if you look at all these things, notice here, not here, this one is at 0. All the voltage is above 0. So if you have all the voltage is above 0, part of it at 0.6 it will get clicked. Is that clear? Now this one here, a small amount is below 0, so it will be also clicked at 0.6 here. Is that clear? Now this one here, if it's halfway, the lower half is obviously get chopped off. And not only that, it must be above 0.6. Is that clear? And so that's how you see. Alright, so that's how you see half cycle and slightly above 0.6. Alright? Now, on the other hand, class AB, you think of it having two transistors. One operate a half positive cycle, the other one operate on the negative half cycle. So theoretically, they should have both cycles operating. But bear in mind that these two transistors will also need at least some small amount of voltage to ensure that base and emitter will be forward biased. And that is about 0.6. So at the crossover, positive 0.6 to minus 0.6, the device is theoretically off. So you see a distortion over at this point. Is that clear? So that is basically why such distortion. One is above 0.6 volt, the other one is below minus 0.6.
Oh, okay. So that means the distortion is like from 0.6 onwards?
Yeah, 0.6 to minus 0.6. Alright. You don't continue, just basically the withdrawal.
Just draw one straight line like that.
Alright, question 5. Now for op-amps, in most of electronic books, this means what? Supposed to be open loop. Okay, but for this particular group of engineers, they use this one as closed and open loop. But having said that in the class, the equation, the generic equation for the op-amp is still correct. That is, your output, V out, is equal to a gain multiplied by V plus minus V minus. Okay, the only difference between open loop and closed loop is, open loop, your gain is almost infinity, very large. Closed loop, the gain is less than infinity, a small amount value. Okay, it could be 10, 20, even up to 100, that kind of things. Okay, now, So for you to work out your output, it's quite straightforward. Ask yourself, what is your gain? Alright? The question gives you the gain. Good. Pick the gain. Multiplied by, see what's your input for your V plus, what's your input for your V minus. Is that clear? Find the difference, multiply by the gain. That's it. Okay? Now, the only thing that you need to note is this. Supposingly, I have a supply voltage. If my output become the value of the gain, multiply already, become a value which is greater than your supply voltage. There's no way for this device to drive your output beyond the supply voltage. Then what happens? You saturate it to your supply voltage. Okay, so let's just see our example. If you look at all these things here, here is 10, right? Gain of 10. So gain of 10, the difference is 1. So 1 times 10, what do you get? 10 times 1 is 10. Now, output 10, is it beyond your supply voltage? No, right? So output stay as 10. Is that clear? Okay, let's look at the other one here. One value is 0, the other is 0.5, 2.5. So 0 minus 2.5 will give you minus 2.5, right? Minus 2.5 times 10 will give you minus 25, right? But what is my supply voltage? Minus 15. So output should be stop at minus 15. Is that clear? Got it? Your, for this case, 0 minus 2.5 will give you negative 2.5, right? Times your gain minus 25, right? But your supply voltage is only up to minus 15, right?
The gain. Where you see the gain? Where you get
The gain is here.
yeah.
That's why you guys never do your tutorial. You never do, then of course. Okay?
So yeah, it's stupid.
No lah, it's just you haven't learned.
It's stupid.
Got it? Now look at here. Look at this case here. Your supply voltage is 30 and 0. Okay? So this is the supply voltage. Now the difference is 2.7, right? 2.7 times 10 will give you 27, right? But your supply voltage is 30. It's still within the range, right? So it retains as 27 in this case. Is that clear now? Any question on this? If not, we move on. Can I?
So yeah, let's say if they never give you gain, what must we do? Is there any way to find out the gain or
If they never give you gain, how do you do? Put out your hand in the exam.
so there is no gain for me? Oh yeah, so we
Okay, the other possibility is your resistance values are given. Then you need to work out what's your gain. Alright, but if it's totally nothing like that, without telling you, it's not possible to work out. So, what must you do? Put out your hand. Ask what's the gain? It could be genuinely there's an error. Now, I like UK system that in the exam, it can be error. You just carry on. They will just adjust it later on, so it's okay. But if you are quite obviously there's error, then you put out your hand and counter check now. Yeah. Okay now, you don't believe me, right? But ask yourself, put your hand on your heart, ask yourself, is it possible for anybody without making any mistakes? Not possible, right? So, in that sense, yeah, okay. So all that you need to do is that sometimes people somehow miss out something which is possible. Or sometimes the value given just make the answer ridiculous. If any time you think that it's a doubt, you can always. But make sure you know your theory well. Is Second. Oh yeah, this one here, one of the year, this was the question, exam question, 10 marks. And the question was very ridiculous. The question was, if I give you 6 volts here, and this open loop gain is, let's say, 10,000. Alright? What is your V out? The answer is it's 5.9999 something. That is the expected answer.
How to get the
How to get that? It's essentially something like that. You have V out is equal to your AB, V plus minus V minus. Okay? Okay. Your V plus is 6 volt, right? So V minus is actually V out. So if you work it out, V out 1 plus AB is equal to AB V plus, right? Okay. So if you work out, V out is equal to AB 1 plus AB multiplied by your V in. Okay? And you plug in the value, it will become 5.9999 something. And that's the expected answer. But it's 10 marks.
What?
Oh. That was 1 year. It really came out.
UK professor, year 1 year.
So I sometimes don't quite understand why they want to ask this type of question, but it is. So, but anyhow, that's why theoretically in UOG they say 1 hour lecture you are supposed to read 10 hours at least. And by right, that is the way the education is. Independent learning. Okay? Alright. So anyhow, what is this circuit called? Voltage buffer, voltage follower, whatever. What is it good about? It is good such that you can isolate one stage to another stage. Okay? Now, on the other hand, if you want to have a op-amp circuit, that will be 100, what do you call it? Gain of 100. What do you do? Well, let's look at the op-amp circuit. Okay, A, B, C. Which one is non-inverting? Which one is inverting? Amplifier. Okay, and which one is positive, negative feedback?
What's the difference between A and B? You're not sounding it. You're just saying
I also don't know. Okay, which one is a non-inverting amplifier? Sorry? Which one is a non-inverting amplifier? Okay, or which one is a inverting amplifier? A no. Okay. How about B? B also. Okay. How about C? C no ball. Okay. The answer also I also see no ball. Now class, first thing I would like you to notice. In LM there are two types of feedback. One is negative feedback, the other one is positive feedback. Okay. Now how do you recognize? Your output go to positive branch. Here, go to negative branch. Okay? Now class, whenever they go to negative branch, it is amplifier. That's correct. Is that clear? Now, whenever it's going to positive branch, it is called Smith trigger. Is that clear? Smith trigger. Alright, Smith trigger. Now, class, as to which one is inverting or non-inverting, it depends on how, look at these two. This supposedly configured as your amplifier. But whether it's inverting or non-inverting, somebody rightly put it, what's the difference? There's no difference. It will only be difference when you put in your input. Is that clear? Now, typically, let me draw just one more. Let me just draw one more. Same thing here. Supposedly, class, I connect my input this way. Okay? Now, in this case, is this inverting or non-inverting? If I were to have input go to here, positive side go to here, which is equivalent to saying that I have this to ground, this one to ground. Is that clear? Can you see that these two are the same? The positive side go to your negative branch. This one go to here is equivalent to this go to here, right? You understand? Now, in this case, my input go to the negative branch. Input go to negative branch, it is inverting. Is that clear? If my input go to positive branch, which means that this one go to here, right? And this one go to ground. Can you see that it is the same, but this time now, your input revert. Is that clear now? Now, if my input go to positive branch, then this is non-inverting. Is that clear? And this will be, what's your gain? Your gain will be 1 plus Rf over R1. Here, your gain is minus Rf over R1. Is that clear? You understand, class? So, just summarize. For you to recognize it as a op-amp, look at your feedback. If feedback from positive output to negative terminal, that is op-amp. To recognize it as inverting or non-inverting, ask yourself, where is my input? If my input is in the negative branch, inverting. Is that clear? And what is the advantage of this positive feedback? The Smith trigger, it can be used as a very clean comparator because it actually reduces the glitches. Alright, this one will reduce the glitches. If you want the previous one, in the previous class, last time I got a complaint that I reuse the paper, but I find it very wasteful. I mean, I'm just, okay lah, it may save a little time. I can always slow down, but otherwise, I'm just repeating it. Is that clear, class? Alright, so just recap. Op-amp means negative feedback. what is the advantage of this? It is basically the ability for you to clean up noise. Alright? You may not need to know very detailed. If you want, you can read it up. But take my word, for positive feedback, one of the advantages is to reduce the noise. It's immune to noise switches. Alright? That is how it works. You can read it up yourself. Okay, otherwise, within an hour, I can't possibly give you everything. I already give a lot already. Professionally, I am. Okay, so once you have that, the answer here, I hope that you know. Is that clear? This one you already got it, right? So it is essentially what I'm saying here. Alright, non-inverting is basically this. Alright, so you just work out your R1, R2. Is that clear? Probably you do not want to copy. If you want, you can always take a photo. It will be easier.
Okay, so copy muscle memory.
Sorry?
You can remember better rather than take photo.
But we only have 1 hour, remember?
Because I stupid.
Sorry?
I stupid. Sorry.
No, the thing is, we only have this amount of time. I try to optimize where possible. Because we still have other questions, right? Yes. So note this. So okay, so essentially, so all these things I hope by now the answer given. Okay? What I was trying to do is to explain all these things here, but add a little bit more. You understand? Okay, this answer you can download it from Moodle, right? So the one I will not go through it. Okay. Now let's look at this one here. Okay, what about this one here? I want to know, okay, the ADC class. Alright, for ADC, what are the things that you need to watch out for? Now class, essentially, the concept of ADC is this. There are a few things that you want to know. Okay, one is what is your range? Supposingly, class, this is the ruler. Okay, this is the range. The distance is the range. Okay, and then you have a step size, a small step size. Now this is basically your resolution. Okay, now as far as this is concerned, these are questions, typically there are a few things. They ask you for the number of bits required for your resolution. Okay, the number of bits required for the resolution. Or sometimes they give you a certain number. What is the value? Okay, so these are the often asked questions. Now the concept will be essentially what you need to do is, and then this one is this is your start, and this is your end. Okay, so to answer this question, essentially what you need to do is your range is given by endpoint minus starting point. Is that clear? Okay, the number of steps is equal to range divided by your step size. Agree? Okay? And the number of bits. Alright? What you need to do is something to ensure that. Is that clear? Okay? And let's say, for a number, a given number, what is the value? What you need to do is, the given number multiplied by the step size, plus your starting point. Is that clear? Alright? And that is basically the idea behind it. Is that clear? Alright? Okay, now what I draw here is essentially explained here in words. Alright, that one you're going to see, but basically it's something like what I say here. Is that clear? Can I move on now? Okay, now the next thing is, you look at here, number 9. I have 3 signal, 1 Hertz, 5 Hertz, and 20 Hertz. Alright, and then I'm sampling it. So, obviously 1 Hertz. Supposedly I have 1 second. 1 Hertz, 1 second is like 1 cycle, right? Agree? So, the waveform will be 1 cycle, 5 Hertz, there will be 5 cycle, 20 Hertz, there will be 20 cycle. Okay, so that is the graph. Now, and then if I were to sample my signal, 20 times per second. Alright? 20 times per second, that means within the 1 second, you need to chop it to 20 interval. Is that clear? Now, once you chop it to 20 interval, you draw a line. When it cut, that means that is the point at which your ADC see the value. Agree? So, if you do the cut, you can see that for the 1 Hertz, your points are very nicely cut. From one point to another point, you can really, if you join straight line, you can see that it is almost like a sinusoidal wave. So this information is quite the same as your analog signal. Now on the other hand, for the 5 Hertz, you realize that if you join them, it becomes like a triangular wave. Okay? Now the worst one is this one here. All these points will cut at the same point within the same phase of the sinusoidal. It appears to be a DC signal. Alright, and this is exactly what it is meant by aliasing. Alright, this is something we call it aliasing.
So that means on your first graph, right? At 0 there is a point, right?
Yeah.
So is it like what, half of it, or it's a full point?
Again, you're talking about here, is it?
Yeah, that one.
Okay, it really depends on when your signal starts. You see. So these are not critical. What is critical for you to note is that now these are the signals that when your ADC go through, after you, let's say, smoothen it, it's still to the computer. It is the same kind of signal. Okay. Allow me to draw a picture, then we'll try to understand what's happening. Okay, let's see. Okay. Now, class, imagine that these 3 people are, let's say Ali. Okay. Ali is a good runner. Okay. Okay, now all these 3 people wear those glasses that they can see at night. Alright? And then there's this flashlight. And then imagine that this is a night time. Alright? So now imagine that there's this marathon champion who can run, in this case, 380 degrees. The big cycle, 380 degrees. In dark. Okay, this flashlight on and off, on and off. So at the moment, when it's on, or at the beginning point. Okay, now the flashlight off for a short while. And these people can run in dark. Okay? Ali, being a good runner, he can run 340 degrees. Now Ame is a very gentle lady, wears skirt. So she runs only 50 degrees. But this marathon champ, is a fast runner, so he runs 380 degrees. So the next moment, when the flashlight turns on again, what do you see? Ali will be at here, 340. Ame will be here. The champion will also be here. Agree? Now imagine that the flashlight keep on and off, on and off, that they are running at the same speed. What do you see? To us observer, the champion is just run as fast as the Ame. Agree or not? Because they were already all both inch by 20 degree only. They are almost equally fast as Ali. But Ali is the opposition. He always run in the opposite direction. Because he will be run 20, 20, 20, 20. Is that clear? So, regardless of how fast these people work, but because I only observe them in at the interval which is less than what their activity is. So to me, it appears that these people are working equally hard. You understand? And this is what is aliasing. Aliasing is when your information in between your sampling is already totally mixed up. And that misrepresents your information. Is that clear? Alright. So for that to be good representative class, what you need is typically I think your lecture note says something like that. Your sampling frequency should be at least 5 times of your analog bandwidth. Right? FA. This is your analog signal. 5 times or better still 10 times. Okay, but what's the Nyquist? Nyquist is 2 times FA, at least. Otherwise, you cannot recover your information. Is that clear? You understand? All right. Okay, number 10, I do not intend to do too much, but basically, it's simply you know, remember the summary sheet that I have? Whenever it's parallel, it's simplified them. Whenever it's series, it's simplified them. Is that clear? After you simplify all already, then you have the simple formula you have for, in this case, what's your input? Input is at non-inverting terminal, so it is a non-inverting amplifier. Is that clear? Feedback is negative, so it is amplifier. Got it? So once you got that, simplify. You get this, and then this is the formula, get your gain. That's it. I would not want to touch too much on that, unless you have any question. Here. So now, we do the very last bit of this. Now, class, I will just explain one. Use one of these. Okay, essentially what do you need to note is, given the reference class, you work out what is your voltage here. Is that clear? Now, happen that there are 1, 2, 3, 4, 5, 6, 7, 8. 8 steps, right? So if this is 8, just nicely, this will be 1 volt, 2 volt, 3 volts, etc., etc. Is that clear? So work out all this, and note here, these guys are connected to, this reference voltage are connected to your negative terminal. Okay? So whenever your input is greater than that particular comparator, output will be a 1. Is that clear? Clear? So now let's look at what happens. Let's say if my input is V in is equal to 4.5. Now if V in is 4.5, obviously up to here this is 4 volt, right? Then this guy will be a 1, 1, 1, 1. All the rest will be 0. Is that clear? Now the next thing what you need to note is this. This guy is exclusive of, meaning it must be either one of them a 1. Both 1, both 0 will be 0. Is that clear? So where is the place that you are going to get a 1? Well, in this case, this is the last one and this is 0. So this will give you this one a 1. Is that clear? So once you got this, a 1, what happened? This one will turn on this, right? And when you turn on this line is the one that will give you a 1. These two lines, when they are not connected, will give you 0. Okay, so for 4.5 volt, you are going to read 1, 0, 0 binary. Is that clear? In other words, your 4.5 is truncated to binary 4.
E5 also 100.
5 volts. Actually, 5 volts. I think this one here, there is a, what you call it? What is the value given? 4.5, 2. Now the 2 one is a bit sticky. You need to make an assumption. If it's slightly more than 2, then your rate. Okay. If it's slightly more than 2, then this will be a 1. If it's less than 2, slightly less than 2, then this will be a 0. Okay? And then you just follow up. Okay, so for the 2, it's a little bit difficult. You need to make an assumption. Alright, qualify it with an assumption saying that 2 plus a small of 2 minus. If you look at your lecture notes, they always do something like whatever value plus a delta. Is that clear? You understand what I'm talking about? Okay. Now, the answer for the one, the 8 volts one is wrong. Class, your tutorial answer for the 8 is wrong because when your input is 8, class, even the last one is a 1. Is that clear? If the last one is a 1, then the one that will give you a 1 will be this one here. Will end up, for the 8 volts, V in equal to 8 volts. Output will be 1, 1, 1, 2, and not 1, 1, 1, 0. Is that clear? Take note of that. Okay? Now for the 2, what answer was given, class?
001.
001. Okay, that means it assumed to be slightly less than 2. Is that clear?
So that one is we assume ourselves.
If you were to write, you put down the assumption, bracket assume. It's okay. Alright? Clear? So far, you're comfortable with the pace? Okay. Can I have a short break? Yeah, go down again.